In this concept, we're going to talk about solving compound inequalities with the words and or, as we'll see later. Okay. Now, if a compound inequality contains the word and, then the graph of the solution is the intersection of the two inequalities, or the two portions of the inequality expression. Okay, let's look at an example of what a compound inequality may look like. So we have this inequality, minus 8 is less than x minus 3, which is less than 4. This type of compound inequality can be expressed using the and word as follows, right? So it can basically be broken down into two portions. This is one portion, right? And this is the other portion. Okay, so the first portion will read like this. So minus 8 is less than x minus 3. This is one part of the expression. Okay, and x minus 3 is less than 4. So both of these parts of the full expression have to hold at the same time. Okay, they're joined by the and word, or the and operand. So the way to solve this type of inequality is to reduce each of the two portions, right, by basically solving for the x, and then graphing them and then finding the intersection. So let's look at how this could be done. So minus 8 is less than x minus 3. We get, we'd like to separate the x's on one side, so we can add 3 here and here, right? So then these two cancel, so we have minus 8 plus 3 is less than x, which gives me minus 5 is less than x. This is one part of the solution. For the other part, we have x minus 3, which is less than 4. We can get rid of this 3 by adding 3. Again, 3 here plus 3 here, so we have x less than 4 plus 3, which gives me x less than 7. So the full solution is the intersection of both of them, right? It's whatever values are common to both parts, or both portions of the expression. Let's graph the first portion first. So minus 5 less than x. So I go to minus 5, right? I draw an open circle because I'm not including minus 5 itself, but I'm including everything that is greater than minus 5, right? So whatever goes to the positive direction to minus 5. This is the solution to the first portion of the inequality expression. The second portion is x less than 7. So I go to 7 and make an open circle, and then I take whatever is less than 7 towards the negative direction. Okay? Now, the intersection of both of these expressions is whatever is included, between the two values of minus 5 and 7, right? So it's all this, it's all this space, right? So it's essentially the space between minus 5 and 7. Okay, this is the solution. Okay, now the solution is the intersection of the two graphs and can be written in the set notation form as, so the solution is x such that minus 5 is less than x, which is less than 7. This is how it's read. Okay, minus 5 is less than x, which is less than 7. The second type of compound inequalities would have the or word. And if a compound inequality contains the word or, then the graph of the solution is the union of the two inequalities, or the two portions of the inequality expression. Okay, let's look at an example. Solve minus 5x plus 1 is less than 16, or 3x minus 6 is greater than 15. Okay, so here I have two inequalities, or two inequality expressions, joined by the word or the operand or. Now, again, the way to approach this is to solve each of them separately, right? Reduce each of them to an x, and then, greater than or less than something. And then find the union of both of them. Okay, so for the first expression, I have minus 5x plus 1 is less than 16. So then I get rid of the plus 1 on this side because, again, I want to separate the x. So minus 1, right? So minus 5x less than 16 minus 1. Minus 5x, so 16 minus 1 gives me 15. And then I have minus 5x is less than 15, so I want to get rid of the minus 5. So I divide both by minus 5. So I have x is less than, now I have x greater than 15 divided by minus 5 because I'm dividing by a negative number. So I have x greater than negative 3. This is my first part of the expression. For the second part, I have 3x minus 6 greater than 15. So again, I can add 6 to both sides, right? So I'm going to have 3x is greater than 15 plus 6, which is 21. So 3x greater than 21, 3x divided by 3, and 21 divided by 3. So I have x is greater than 7. Okay, so now if I graph each of them separately, I have x greater than negative 3, which gives me, I go to negative 3, and then I take whatever is towards the positive direction of negative 3. And then I also go to x at 7, and then I take whatever is greater than 7. So the union is whatever is in this space, right, as well as whatever is in this space, right, because it's the union of both of them, the union of whatever is included in both graphs. So it's essentially whatever is greater than negative 3 towards the positive end, right? So the graph x is greater than negative 3 contains every point also that's also in the graph of x greater than 7. The solution is the union of the two graphs, can be written in set notation as x such that x is greater than negative 3. Okay, now let's look at some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so we need to solve the following inequalities. So this inequality has the and word, right? The two portions are joined by the and word. So I can break this compound inequality to two expressions, or two portions. First portion is minus 1 is less than x plus 4. The second portion is x plus 4 is less than minus 6, right? So the first portion would become, I can subtract 4 from both sides, right? So I'm going to have minus 1 minus 4, which is minus 5, is less than x. And then for the second portion, I can also subtract 4 from both sides. So I'm going to have x is less than minus 6 minus 4 is minus 10. Okay? So this is my first part of the solution. This is my second part of the solution. X is greater than minus 5 and x is less than minus 10. So if I create a number line, right, and I have, 0, minus 5, minus 10, etc., 5, whatever. So x is greater than minus 5 will give me this, whatever is towards the positive end of from minus 5, and x is less than minus 10 will give me this, whatever is towards the negative end from minus 10. Now I need the intersection of both of these portions, but I have no intersection. Okay, they do not intersect. So my solution is actually that there is no solution. Okay, there are no values that satisfy this inequality. Okay? No values on the number line of real numbers satisfy this inequality because there's no intersection for both portions of the solution. Let's look at the second exercise. So we have minus 2x plus 1 less than 9, or x minus 3 is greater than 4. So I can solve the first expression separately. So minus 2x plus 1 is less than 9. Gives me, so I can subtract the 1 from both sides. So this gives me minus 2x less than 9 minus 1 is 8, right? Which gives me, I can divide by minus 2, divide both sides by minus 2. So these cancel out and the sign gets flipped. The inequality sign gets flipped. So I have x greater than 8 over negative 2, which is negative 4. So this is my first part of the expression. My second part of the expression is x minus 3 is greater than 4. This gives me, I can add 3 to both sides, so x is greater than 7. Okay, this is my second portion of the expression. Now, if I attempt to graph this on the number line, now I have 0, minus 5, plus 5, plus 10, minus 10. So x is greater than negative 4. I go to negative 4 and I make an open circle, right? So x is whatever is greater than negative 4 on the positive side. But x is also greater than 7. So 7 is somewhere here, right? And I'm going to take whatever is to the positive end from 7. So the union of both expressions is this entire space, right? So this is the space for one expression, and this is the space for the other expression. So the union is the entire space. So my solution set is essentially x such that x is greater than negative 4, right? Because x greater than negative 4 actually includes x greater than 7 also. Okay? This is it for this concept. See you in the next video.